Hi, in this video we are going to talk about the difference between list multiplication and list comprehension in the context of another way to initialize a 2D array. So we have all seen how to initialize a 2D array if we know all the elements in the array up front, right? So in this case, we can specify all of them when we instantiate 2D array. However, what if we don't know all the elements up front, right? Or in other words, what if it's okay to just make a space so that we can store this 2D array, but initialize all the elements to like some sensible defaults like zeros. Now, obviously, we can just put all zeros here, but what if the array is huge, right? 100 by 100. We really don't want to type, 100 by 100 zeros, which is 10,000. So as usual, in programming, there's a quick way to do things like that. And here it is one of the ways. So we can do this. It might look a little complex, but I will break it down for you. So this is this is a list comprehension. Okay, so you can see that by with the kind of the bracket, square bracket, and inside it for something. That's something because we don't really care what that is. I mean, all that we're trying to do is we're trying to repeat whatever we're doing here 3 times, right? Okay, and so this is going to create a list with 3 elements. Now, what each of these elements are is this is a list multiplication. And it's going to create a list with 4 zeros. So this would be what we consider the inner array. Okay, 4 zeros. And a list of 4 zeros, and it's done 3 times. So this effectively then creates a 2D array of 3 rows. Each row is a list of 4 elements. So I have the code here, and let me run that, and that's exactly what it is, a 2D array of 3 rows and 4 columns. So you might wonder, why are we using list multiplication and then list comprehension? So, and there is a good reason for that. So in order to understand it, the first thing that we want to review is what is list multiplication. Okay, now we all know what list concatenation is, I assume by now, that given lists, if we kind of just add them together, we're going to have one list with all the elements in each of the lists that we're adding together. So this is one example. Another example I typed out here is if two lists, short list, first list is 1, 2, second list is 3, 4. We add them together. It's giant list of one bigger list of 4 elements from all of these separate lists, right? So far so good. Now, what multiplication is then is if each of the lists we're adding together, if they are exactly the same, if it's that, then instead of adding them together, we can just multiply them. Okay, just like additions, if we're adding 2 numbers that are the same together, we can just multiply by 2, right? So that gives us the same thing. So that's list multiplication. And that's what this slide says. Now, given that, you may ask, then why don't we use multiplication here again, right? Why do we have to use comprehension? So if instead of using list comprehension here, if we just multiply the list 3 times, then we should get a 2D array, right? And if you actually run that, that's what it looks like, which seemed to be correct. But as they say, looks can be deceiving. So, so let me actually uncomment this. So this is using multiplication and then comprehension. This is using multiplication and then multiplication. Now, if I run this, so far, these two ways, they yield identical 2D arrays. Now, if I change, let's say, the element at the top left corner of this matrix or 2D array, as we would kind of expect, only that element is changed. What if, though, you do the same thing with this matrix here, or this 3D, 2D array? All right, let's run that. And surprise, surprise, this way, not only it changed the first element of the first inner array, it also changes the first element of the second array and as well as the third array. So why is that? Well, the difference is what each of the element in this comprehension and this multiplication points to. And so let me explain. So let's look at the multiplication case step by step. So the first thing, list of 0 multiplied by 4, that creates a list of 4 zeros, right? And that's one element in another list. So what this yellow part is, then it's a list of one list of 4 zeros. So it's a list just that has only one element, and that one element points to a list of 4 zeros. Okay, now and then when we do the multiplication again, the important thing to note is that when we do multiplication, each that element, that one element gets multiplied by 3 times, quote unquote. So we have a list of 3 elements. Now, each of the elements in this new list references the same element in this list. And again, this element is a single list. So that's where the problem lies. And again, multiplication, the new list that results from list multiplication, each element in that list points to the same elements in the original list. And this is why when we seem to only change one of the elements in one of the rows, right? Let's say we're changing, row 0, the first element. That's why we see the same change in all the other rows, right here. Because all the rows, they are the same row. All right, so I hope that makes sense. Now I'm going to take you to think even a little deeper about list multiplication. So let's forget about the 2D case for a moment. And if we just look at a simple 1D case, right? A list of one number 0 multiplied by 4. So if we say the list multiplication creates a new list, each element of which points to the original elements in the original list, then this expression would create a picture that looks like this. But then if we change one of the elements in this new list, then wouldn't we change the 0 to 33, and wouldn't we get a list of 4 33s? Now if we do this and if we run it, what we see though is that we indeed only change one of the elements instead of all 4, right? So wait, something doesn't quite seem to match here, or does it? So one of these two pictures is wrong, and our explanation of list multiplication is correct. So what's not correct is this picture. So if you recall, the assignment operator, what it does is it changes associations of the left-hand side. So this, when we assign 33 to an element in the list, we are changing what that element points to. So originally, they all point to 0. When we assign a new value to one of the elements, then that element points to the new object, in this case, the int object of 33, but only that element. Right? The rest of the element, because we did not change it here, they're still pointing to zeros. Okay, so that's why we saw what we saw. So that's all I want to say for list multiplication. So now let's look at list comprehension, what it actually does. So let's look at, so this is a list. Now for each of this list, for each element of this list, it creates another list of 4 zeros. Okay, so that's a list of 4 zeros. Now this 4 underscore in range, it basically repeats this operation 3 times, once for each element of the new list. So in some sense, the list comprehension actually creates separate copies of this list of 4 zeros. So that's the picture we ended up with list comprehension. And this is different from if we use list multiplication here, where we ended up with just a single list, but all 3 elements of the outer list are pointing to the same inner list. And I hope now you can see why if we just change one of the elements, it won't affect all the other rows. And that's why list comprehension is the right way to do this. And to help you to further understand the difference between a list comprehension and a list multiplication, I would ask you to try this little exercise yourself. So these are, we're showing the 2 different ways to initialize the 2D array. Now for each of these 2D array, you should print out the ID of each of the rows. And you should then look at the IDs and make sure the values match your understanding. And to give you one more exercise on this topic as well as 2D array in general, please write a function to transpose a given matrix. So transposing a matrix is actually a very, very common operation, and that involves just transposing or changing each row into a column. So 1, 2, the row becomes 1, 2, a column, and 3, 4, a row becomes 3, 4, a column. So please pause the video and give this a try. All right, so assuming you've done that, I'll show you my code. So the first thing I do here is I like to get the number of rows as well as the number of columns from the original matrix. And number of rows is basically just the length of the outer array. And then the number of columns is the length of one of the elements of the outer array, right? So that's the length of a row. Now, obviously, this only works if this is a this is a rectangular array, a 2D array, where all the rows have the same number of columns. So anyway, next I'm going to initialize a new matrix. And now the shape of that new matrix is the number of rows of the original matrix becomes the number of columns, right? So that's this, right? That initializes one row, and the number of columns in that row is the number of rows in the original matrix. And then the number of rows we're going to get in the new matrix is the number of columns of the original matrix. Next, we are iterating through the original matrix like we always do. We iterate through the row indexes, and then inside that we iterate through the column indexes. And for now, for each of the entries from the original matrix at the row and the column, we're going to assign it to the new matrix, and the element that we're going to assign to the new matrix for the row, we're going to use the column from the column index from the original matrix, and the column index is the row index from the original matrix. So that's kind of the definition of a transpose, right? That basically the row becomes column, and the column becomes the row, and at the end we return the new matrix. So here is an example of that, and if we run it, we see that the first row is the first column of the original matrix, 135, 135, and the second row in the new matrix is the second column of the original matrix, 246. So hopefully that makes sense. But if you want step through this example kind of line by line, and make sure you understand this.